My name is Igor Sysoev. I'm original author of NGINX Observer, and also I'm co-founder and CTO of NGINX company. I will tell about NGINX Unit. It's our new application platform. The talk has alternative name, Securing Development for NGINX, because it's Cyber Protection Conference. I will tell you about Unit and will emphasize on security features of our project. So, for the start, the history. I started to develop NGINX in 2002, and after 2 years of development, I made the first public release. In 2011, I and two co-founders decided to found the company. And now, according to statistics of Web3 text, 66% of top 10,000 sites use NGINX. Currently, we have more than 300 employees in 6 offices. The headquarters in San Francisco. Also, we have offices in Cork, England, Ireland, Moscow, Singapore, Sydney, and on the next week we will open office in Tokyo. We developing several products. First of all, we continue to develop NGINX open source software. Also, we released a commercial product, NGINX Plus. It is based on NGINX open source with advanced load balancing capabilities and advanced monitoring. The other rather small project is NGS. This is our own JavaScript implementations. This implementation is intended to be embedded inside NGINX, designed for NGINX. Another big our project is NGINX Unit. This is application platform, and I will talk about this product. Also, the last but not least, we have NGINX controller. This is commercial control plane to manage NGINX Plus instances. So, what is NGINX Unit? NGINX Unit is a web server that is able to run applications. Currently, we support 6 languages. They listed in order of their appearance in the product. Python, PHP, Go, Perl, Ruby, Node.js. And in this month, in the February, I hope we will release Java support. NGINX Unit runs on Linux, FreeBSD. Also, we support macOS because we develop, many developers use it, and Solaris. And of course, NGINX Unit is designed with security in mind. I will tell how we provide security in the unit. The one of the key features of NGINX Unit, which I personally very like, is new configurations. The first of all configurations is just JSON, JSON format. There is no configurations file at all. You can configure Unit only with remote RESTful API through the network. You can dynamically reconfigure NGINX Unit completely or just some parts of the unit. Later I will tell how we will do it. So the history of NGINX Unit. In September 2017 we released on our conference the first public beta version. On April 2018, we released the first stable version, version 1. And in the end of the previous year, we released our latest version is 1.7. Sorry. NGINX Unit is open source and licensed by Apache 2 license. You can find documentations and can download Unit on the site, unit.nginx.org. Also, Unit is available in repositories of many Linux distributions, and you can track development on GitHub, open issues, and participate. So this is architecture of, slightly shifted. Okay, this is architecture of NGINX Unit. A unit consists of several processes. The green processes are the processes that written by our company, and the the picture is completely different what I did. Well, and the blue process run PHP interpreter, run different languages interpreters, run frameworks and applications which users develop. So let's talk about a controller, because controller is one of the key things of the project. Controller process handles configurations via remote RESTful API. Also, it stores backup copy of configuration to use it at start. It actually is a file, but we didn't promote to use these files as initial configurations because these configurations will be rewritten after every change by controller process. For security reasons, controller runs by unprivileged users and listen only on local, should be listened, actually it can be listened on every port, but we suggest that you should configure it that it should listen only on local host interface or Unix domain socket. This is how configurations looks like. This is JSON. It's very simple configurations. You can see the listener. So it says that unit should listen on usual HTTP port 80, and all requests that comes to this port should be passed to application block. Application block is PHP. It should be run by special user VP users. Application should use no more than 5 processes, and other configurations, root and script, tells where PHP should find the scripts. In February, we also add capability to route requests based on host header, or based by URI, or some by method, HTTP method, or by HTTP headers, appropriate, arbitrary HTTP headers. This is how RESTful API looks. You can use browser, you can use curl, you can use, you can write your own configuration interface using JavaScript, and this is how you can configure unit. For example, if configurations stored in files config.json, you can put it with the first command. You can read configurations at any time the second is just a GET request to the controller process. Also, you can read just part of configurations. For example, you can look listener configurations. And you can change a whole configurations, as you can see on the first command. And you can change just one parameter, for example, or just part of the configurations. For example, in this command, we change number of processes from 5 to 10. And also, you can put SSL certificates to the unit to use them for HTTPS. This can be done with the last command. So this is what controller does. Let's talk about router process. The router process works with internet, with clients, and it passes requests to application worker processes. As well as controller process, router process works under unprivileged users. This allows to minimize damage which can be occur if the router process will be exploited by from external users from internet. Router process has several worker threads, and each threads listen on each own ePOL or KQ, depending on the platform interface, and can handle simultaneously 1,000 connections. We choose this approach to minimize locking inside the unit, and several threads allows you to utilize multi-process systems. And each thread is able to work simultaneously with several generations of configurations. If you ever work with NGINX, you probably know that when you change NGINX configurations, you have to reload it. And NGINX spawns new worker processes, and if there is some long-standing connections between clients and worker processes, workers can live for a long time. It may live hours, days, and months. And it was acceptable a long time ago when NGINX was started, because it was intended, NGINX initially was intended to run on very high loaded cases. But now, in cloud environment, the configuration changes became very frequent, and after several hours of running NGINX, if you will change configurations every minute, for example, you will have a lot of worker processes that eat memory. In Unit, router process is able to run with many different versions of configurations, the current one and all previous. After all requests that should be processed in the previous configurations will complete, these configurations will be destroyed from the memory, and this approach allows you to minimize memory overhead for the old configuration. And the next process is main. Also, the name is main. It actually doesn't do many things in Unit. This process is initially started, and it spawn and respawn router process, controller process, and application worker processes. The main process doesn't listen on any ports for security reasons, and usually it run by privileged users, something like root. And this is the root is required to listen to bind listener sockets on privileged ports, the ports below 2024. Also, it creates log files. All these things the main process does on behalf of the router process. So router process asks to open listener ports, and all should be done. All this work should be done by main process. And finally, we will talk about application processes. Applications that can be run by unit can be divided into groups. The first one is drop-in replacement. So if your program developed in PHP, Python, Perl, or Ruby, you don't need to change anything in your application. You can just configure unit to run it, and all should be done. This is drop-in replacement. The second group of the applications are written in Go and Node.js. They require, and Java, upcoming Java, they required to make small changes in application code. For Go, you need to add import NGINX Unit package and change one line and to use unit instead of stock HTTP package. With Node.js, change is similar. However, the changed Go and Node applications can be run as standalone applications, so you can run it without unit, because these packages provides a fallback to generic HTTP processing. So you can, for example, if you're more convenient to develop your applications as standalone, and you can do it, and then you can just put this application to the unit environment and run it on the unit. Applications processes run under unprivileged users. Each application can use different users. The applications processes spawned by main process, and if applications will fail, the main process will fail or exit abnormally. Main process will respawn it. And unit, one unique feature of the unit is that you can run simultaneously several versions of PHP. For example, PHP 5, PHP 7.0, and PHP 7.3. The same is for Python, Perl, Ruby, etc. It's helpful for graceful application upgrade. For example, your application currently works on PHP 7.2, and you can, with one configuration change, you can try it to run with PHP 7.3. Also, it can be helpful for A/B testings, etc. How application processes communicate with the router? The main channel of communications is UNIX socket pair for control information, and for bulk data transfers we use shared memory segments. However, this approach is different from usual. The shared, for example, in Postgres, shared memory you shared between all the worker processes that Postgres use, and this is common approach. We use a different way. We create this shared memory on demand, and these shared memory segments are private to each worker. So if some worker, application process worker, will write some malicious data to this shared memory segment, it will not affect other processes. And another thing, if, for example, the application's process will exit abnormally and will leave this shared memory on the inconsistent state, router will just drop this shared memory segment, and this will not. It will be no. This will not affect other processes. So, in short, NGINX Unit is application web server that are able to run web applications written on these languages. It supports dynamic configurations with JSON format and remote RESTful API, and designed it with security in mind. That's all. Thank you.
Igor, thank you very much for all your insights. Now we're going to proceed with Q&A again. So just like I said before, please be precise, brief, and state your name. Any questions? There's two gentlemen out there.
Thank you for your presentation. My name is Georgi. My question is, do you plan support for .NET Core, and what are the challenges there?
Sorry, you asked about .NET Core.
Yes, .NET Core.
So will we support it? We have planned to support .NET Core, but its support of .NET Core is always the same difficult like support of Java. We spent a lot of efforts to support Java. The other problems with .NET Core that I don't know actually if it really used in Unix environment. So I know that the .NET Core is very popular in .NET is popular in Windows environment, but I don't know, is it really currently wide used in Unix? I don't know, in Linux, for example. So if we will see a lot of demand of .NET Core, we will add it eventually. But currently, we have no plans to support it. Actually, when I said about two types of languages, Python, PHP, Ruby, Perl, these languages was designed, not actually designed, but have interfaces to embed in some service. For example, in Apache, you have you know that there is mod PHP, mod Python, mod Perl, mod Ruby. The Node.js, Go, and Java, they have no such interfaces to embed in some servers. They usually run like standalone servers. And .NET is the same. It belongs to the second group. The first type of languages, Python, PHP, etc., it was relatively easy to add support of these languages to the unit. It takes, for example, we added Perl support just in months. The same for the Ruby. And it takes about half a year to add support to the Node.js because it's completely different architecture.
There's one more gentleman out there.
Здравствуйте, Игорь. Спасибо большое за презентацию. My name is Anton. My question is regarding Apache. Comparing to Apache, what are the pros and cons of NGINX? Спасибо.
Could you repeat in Russian? It's much easier. Apache.
Сравнивая с Apache, плюсы и минусы NGINX.
Сравнение, comparison Apache and NGINX. NGINX or NGINX Unit? Yeah. Okay. Apache, why I started to develop NGINX? I worked in Rambler, and we have a lot of Apache instances in our company, and Apache has scalability issues. You cannot, in Apache, each request should be processed by separate worker, one process worker. The things changed later. Now Apache can run, it can be multi-threaded, but anyway, each thread is bound to the request. So if you have 10,000 requests, you have to have inside Apache 10,000 threads. If you have 10,000 simultaneous requests, NGINX can process these 1,000 requests in just one worker with just single thread, because NGINX is single-threaded applications. Later, I added several worker processes to NGINX to utilize multi-CPU systems. So NGINX in general more scalable than Apache because it uses EPOL, QQ interfaces to work with connections. Of course, this benefit has, this approach has not only benefits but drawbacks. It's quite complex, quite difficult to program inside NGINX. To program some Apache module, even in C, is much more easy than to program it with NGINX. I personally developed two Apache modules, one for compressing and one for proxying. So it was predators of NGINX. So with Unit, we have the same approach like with NGINX, but instead of several worker processes which work with clients, we use the single router process that works with external clients. And the reason why we use it, why I did not use threads 16 years ago, because the thread support was poor in Linux, in FreeBSD. FreeBSD was our main operating system at that time in Rambler. Probably only Solaris had good thread support at that time. Now things changed, and Linux have beautiful thread supports. The same I should say about FreeBSD, for example. So this is the reason why we use in router several threads. It's similar. It's very similar. We did in NGINX with workers, but the advantage of several threads in router is that they can share space, memory space between the threads. And with NGINX, we have to use special shared memory segments to share this data. And program with this shared memory is it's complicated. For example, if some worker damage shared memory segments, all other workers can stack on this. With router, with multi-threaded applications, this process will simply abnormally exit. So it's more easy to recover.
Thank you.
Yeah.
Do we have more questions? There's a gentleman out there.
Thank you for your presentation. It was very interesting. As a developer, I wanted to ask you something. So far, I have been always deploying my apps in containers. And again, as a developer, this was a huge pain to me. Now you suggest that we use them as unprivileged applications. Would you be able to give short pros and cons of the two approaches?
I didn't understand completely. You said about
containers,
pluses and minuses of containers.
Against apps on the host system under unprivileged users.
Against monolithic applications against containers applications, yeah? Oh.
No, I was. It was more about running your applications as just processes under just a normal unprivileged user on one hand, and then containers like Docker on the other.
Sorry, I still can't get. So the question is, what benefits of running containers against monolithic systems, or what? Or usual. Okay, so
Just
yeah.
please be very brief. We don't have much time.
Okay, well, the current popularity of containers, the Docker systems, I believe, is that Docker allows you to isolate applications. Usually people think about containers like that. Containers allows you to run, for example, some applications in shared environment. For example, one application for one user, another application for other users, and this approach allows you to run, for example, shared hostings. But shared hostings, I believe, is quite niche market, and what Docker did, Docker allows you to, for example, you as developer have some applications written in Python, and you need to upgrade it. Or, for example, on one host you have several Python applications. One was written on .7, one written on .7.5, etc. And then you need to upgrade Python. For example, there is some security exploit and security issue. You need to upgrade Python. And when you upgrade the Python that's shared between several applications, probably some of your applications will not work after this upgrade. What containers allows you to do is they allows you to completely isolate your applications. You have container with some Python 2.7.1. You have another containers with Python 2.7.5, and they completely independent. If you upgrade your code in one container, it will not affect in any way the applications in other container. So this is a real reason why Docker became popular, because container system actually exists maybe 20 years. It was started by Solaris Zone, in FreeBSD there was jails, and all that these systems, these subsystems allows you to do is just isolate users or isolate networking, etc. But the real problem of the developers was isolate applications, not the users. Actually, many developers can run several containers and the same users on the system because they don't care about security issues. They care only about maintainability of their projects. This is my opinion.
Thank you very much.